All you need to do in Postman to do performance testing is to export your collection, write a very simple script that will take this collection and run it in parallel, say for example for 1000 times. Run the script. Oh, what's this? Hi there, and thanks for joining me for this tutorial. Today I wanted to talk about performance testing or load testing in Postman. What we are trying to do with such tests is to see how the application behaves when many clients use the API at the same time. Now, I won't get into the various types of performance testing as they all have something in common: the ability to send a significant number of requests during a sustained period. Now, if you don't have a lot of time, let me give you the gist of this video right now. While Postman is a great tool for functional testing, it is not really the best tool for bombing an API with tons of requests. While it would be great to have a single tool for all our API needs, testing the performance of an API is really not an easy task. Alone, the fact that there are tools dedicated to this type of testing should give you an idea of how complex this topic really is. So using a dedicated tool is the only way to go if you're testing an enterprise-level API. So if you're serious about performance testing, you may want to look into tools like JMeter, Gatling, Locust, or K6, which I'll briefly demonstrate in this tutorial. So let me show you what I mean. Okay, so let's jump into Postman. I have developed an API and I have deployed it to AWS. And I've used Postman throughout the entire process for testing it on my local machine to see if it works, and also against the AWS infrastructure where this API is deployed. As you can see, I have here various endpoints, and for each individual endpoint, I have created tests. I know that the functionality of this API is sound, so it works exactly as it's supposed to work. Now I'm at the stage where I'm wondering how much traffic can this API or how much traffic can my application handle. I don't know anything about this at this point. I know that I don't have a great design, and one of the reasons is I'm using a file-based database. So every time I'm trying to write something, that will cause problems on the server. And also the server is the cheapest virtual machine that you can get on Amazon. It doesn't have a lot of RAM, doesn't have a very powerful CPU. So it's going to be a great testing scenario to break this API. Let's begin with the basics. So I know that writing to this API is a problem. So for that reason, I have isolated here only one endpoint. And this endpoint creates an order with some random data. And as you can see, locally, when I'm trying to run this, it's providing a pretty decent response time, could be better. I have here Postman tests that ensure that the request has been successful, that I'm getting back a status to 1 created. So everything is working fine. Now, the problem is, how do I know how many users my application can handle, or at least how many orders can I take at the same time? For that, we can run, for example, the collection using the collection runner. And let's say what happens here if we run 1000 iterations. This will take a bit to run. Right, now we have run this collection, which essentially includes a single request 1000 times. We can take a look at the results. We'll see here passed 1000 times. So what does this mean? Well, it only means that our API was able to handle 1000 requests, but these requests weren't sent in parallel. Essentially, we have sent one request, we have waited for the response, and then sent the next request, and so on. For that reason, this is not any kind of performance or load test because it puts no load on the system. The load itself is very, very small. It just sends one request after the other, but we don't really know a lot about this API and how it's working. So for that reason, simply using the collection runner to simulate load is not the way to go. So what I'm going to do is I'm going to go ahead and export this collection. And we're going to use Newman to try to run this request in parallel, see how that works. All right, so I have here a very small project. I have exported a collection here. And I also have this script, which is also available in the GitHub repository from Postman. It is a simple script that allows you to run a collection in parallel. For example, let's take here give a size of 1. So I'm going to try to run this once. I'm going to open here node, parallel collection runs.js. Essentially, we have now tested our script is working, and we have executed the collection only once. Any tests that were inside were also executed. So now if you run it once, it's working. So that's a good start. Okay, so let's now try to run it 100 times. So I'm changing here the number to 100. And what's happening right now is essentially we're starting 100 instances of Newman, essentially, where Newman is running this collection, is sending all these requests out, and then at the end it's collecting all the results. And you will see here we get back a list of all the collection runs and all were successful. We don't see any errors here. So far, so good. Now we know that this API can handle like 100 requests at the same time, or which were sent almost at the same time. But we're not really sure about the limits. And as I was saying in the beginning, I know that this is a very crappy API, on a very crappy infrastructure. So I really want to get at a level where I can see what is the limit of this API. Let's try to increase that number. So instead of 100, what about 1000? I'm going to run the command again. And this time I'm going to also open the performance monitor on my computer. And as you can see, the CPU for Node is already pretty high. And also the memory for the Node process is continuously increasing. So memory and CPU still pretty high and going up. Okay, and finally, Node will crash because it will reach the allocated memory, and essentially we will not get any information about our runs because the entire script failed. The Node essentially failed on the computer. And of course, we could go ahead and increase Node, increase the memory allowance for Node, but you can kind of see that we're getting at a limit in terms of using Node, using Newman in order to run this, let's say, performance or load test against the API. So far, this hasn't been very successful. And even if it worked, the way this test was structured is not something that really replicates a realistic scenario, because we want to be able to send requests over a sustained amount of time, not just send 1000 requests at the same time. Maybe we want to start with 100 requests and then increase that over time. So in a way to simulate it like real users would use the API on a production server. For all these reasons, it seems that using Newman in order to load test our application is not really the best way to do it. Essentially, Postman and Newman, they have been designed for functional and integration testing. They haven't really been designed for load testing. So I wanted to introduce you to a proper load testing tool. And this tool is called K6. It is an open source tool. It's pretty easy to install. It doesn't have a graphical interface like Postman does. But if you're familiar with JavaScript and you're not afraid of coding, and you will see that it's quite easy to get started with this tool. And I just want to do a quick demo so that you can see like how a proper load testing tool works and what kind of an information we're getting back. Now, if you want to install this, that should be pretty easy. I'm going to go here to the documentation, and you will see here in the installation part, you can essentially install it on any operating system, including Windows or Mac OS. For Mac OS, I've used Brew to install it. For Windows, there's also an official package, or you can use this package manager. I will find a link to this in the video description, and also if you're using Docker, there's also a Docker image available for that. So in order to test if this is properly installed, I'm going to simply run K6 version, and you will get back the version. How do we run K6 against this? Essentially, I only have one endpoint, but how do we run it against this endpoint? This is the JavaScript, and this defines essentially the test, our testing scenario. And in this case, it's very, very simple, but still kind of realistic. So it's not a simple GET request that I'm showing you here. This is actually an HTTP POST request that goes to this orders endpoint. I'm providing some headers, also an authorization token here in the address. I'm providing here a body, also added some randomness. And most importantly, what K6 allows us to do is to specify virtual users. So in this case, let's go ahead with one virtual user. And we're going to run this test for a duration of 1 second. And you'll see here that every time this endpoint is called, there will also be a sleep. So essentially, this is in seconds. So when one virtual user runs this endpoint, it waits for 1 second and then it tries this again. Additionally, what we have specified here are also some thresholds, which typically are very important for your APIs. So if you're really serious about deploying this API to a lot of people, most of the time you will need to ensure some kind of requirements in terms of response time, for example. So we have one virtual user and we're running this test for 1 second. So let's see how it goes. So I'm going to run here K6, run script. And now K6 is starting. And it will also give us here an overview of what's going on. We only had one virtual user. And in total, there was only one request that has been executed. There was essentially not enough time to run multiple requests in this time frame. We are now sure that this is working properly. And we'll see here that everything is working, let's say, within expected parameters. And there are a lot of information. There's a lot of information that's coming back here. For example, here we have established that the maximum duration that we expect to be below 1.5 seconds. So we're getting here like the average value, the minimal value, the median value, the maximum value that someone encountered, but also like a percentile of the people that tried it out. This will make more sense once we increase that number. So let's go back to the script and let's say we want to have 100 virtual users. And they will be calling the API over a period of 30 seconds. Run it again. And the nice thing about K6 is that it will show you like in real time what is happening. It gives you a progress bar. You'll have an idea when this will complete. So it's not just executing a script and then watching your CPU and memory go up and not knowing if this will crash or not. So now we already have more data that we can compare. And we can see here that this expectation that we have set here in regards to the duration of the request, now the data has changed. So the average for this API is now at 3 seconds and something. But fortunately, we're looking here how many requests have failed. So 0 requests failed. So the API with 100 users was still able to take these orders. It took a bit longer, but it's still working. So that's kind of like an important thing that we should know about. But I said my objective for this one is to figure out like how many users are required to make this fail. So let's increase that even more. So I'm going to go here with 1,000 virtual users. I'm going to keep the duration of 30 seconds. I'm going to run it again. And now you'll see here, we're getting some warnings because some requests are failing. Essentially, when this happens, it simply means that the machine itself is overwhelmed. It's not taking any requests or essentially the tool is not getting any responses back. So essentially, we're reaching now a level we're really at the limits of this. So I'm curious to see how many of these requests were still successful. But obviously this API, like from the number of errors that I'm seeing here, this API cannot handle so many virtual users. All right, so now we have the report. And we can now notice that if we're just looking at how many requests failed, 85% of the requests have failed. So only a fraction of the requests we have sent out were successful. In this case, even looking at the request duration is not really that relevant because it hasn't really worked properly. And you have seen, essentially my system has not been under stress. I was able to get this report. So now I know, okay, this API can handle 100 virtual users given this execution time frame, which of course you can make longer. But I know it cannot handle 1,000 virtual users. So I kind of like have an idea of the system, and I can also go a bit deeper, look at the server, see which logs have been generated, see what the problem is, try to find out where the bottleneck is. But from this performance load testing point of view, it has been a very, very useful tool for me. It has allowed me with minimal amount of code to go deeper and to understand what my API is doing and how my API will behave if I'm sending lots of traffic all of a sudden to it. I hope this tutorial was helpful and that has given you an understanding of what to expect from a load testing tool and why Postman and Newman are not necessarily the best choices out there if you need to do something like this and if you're really serious about APIs. If you want to learn more about K6, let me know in the comment section below. If I'm getting a lot of positive responses from you, I will continue creating tutorials around K6 and I will show you how to use K6 to do performance tests on your APIs. Thank you for watching and see you next time.